When you're building in the AWS cloud, you're going to make mistakes. And you know what? That's okay. That's part of the process. And really, there's two kinds of mistakes you're going to make. The ones that you had no clue were coming, they came out of left field and they knocked you senseless. And the others that, in hindsight, you probably could have seen coming and done something about. But you know what? Both are going to happen, both are okay. And why is that? Well, because the AWS cloud is full of possibilities. We get a mountain of new services and features and functionality right here at AWS reInvent. And over the last few years, AWS has absolutely spoiled us with new functionality. There's just no way that you can possibly keep up. Even all these great icons you're seeing right here is just a tiny fraction of what's available today in the AWS cloud. How could you ever know the ins and outs of all of these? You're not going to be able to. So you're going to fall into sort of a natural IT pattern that's developed over the years, over the decades, and it gets even worse it's more prominent in large enterprises, and that's going looking for a solution. You want something that's going to solve these problems for you, and those are the best practices. I gotta tell you, I gotta be honest, I don't like best practices. I don't like the word best practices because it infers that there's only one way. There's one way to do this. And we know with a multitude of possibility in the AWS cloud that that's simply not true. If you think there's one way to do it, you're not asking the rest of the question. It's based on a certain amount of constraints that you have right now, on the situation that you're trying to deal with. There's a whole bunch of variables here that you can't just boil down to one thing to do for each solution. So let's give the big thumbs down to best practices and look for something better. Of course, that's a huge setup. There's absolutely something better out there, and it's called the AWS Well Architected Framework. Now, this framework, you may be thinking, wow, this guy's selling it like it's unicorns and rainbows. It's not. I'll be perfectly honest with you. It's a series of white papers presented as PDF documents. At least that's the start of it. There's an overview paper, then some sub papers, but it's what's contained within that's really amazing. This was built off hard-fought knowledge from thousands of AWS customers, thousands of AWS engineers and ProServe teams from around the world who have poured their knowledge into this to help you understand how to build better, how to build well. Now, there is actually a tooling component to this. If you go into your management console, you're going to see something called the AWS Well Architected tool. Here we are in the middle of a review, drilling in on the security section, question 4. And you'll see here something that looks an awful lot like a best practice. Configure service and application logging. You can even see right in the example, ensure that AWS CloudTrail, Amazon CloudWatch logs, Amazon GuardDuty, and AWS Security Hub are enabled for all accounts in your organization. That's great advice. You should absolutely follow that. That would be considered a best practice. And I don't like them, so that was a big setup. Because while you should turn this on, you need to go that extra step. What are you going to do when CloudWatch Logs raises an alert? When Security Hub presents you with a finding? How is your team going to react to that data? I'll tell you from experience, and I'm a security guy at heart, so I'll use a security example. If you go before the board and say, we had no idea this attack had happened, it evaded all of our metrics and monitoring, and we're responding to it appropriately now that we know about it, that's one thing. To have that same conversation with the board and say, hey, we knew about it because our systems alerted us and we had no plan to take advantage of that alert, which conversation do you think is going to go better? So setting this self up, absolutely a fantastic practice to follow, not a best practice, but a practice. What you need to do is then figure out how you're going to use this information. That's the difference. It may seem like I'm splitting hairs here, but it's super, super important to understand. So the framework itself is divided across 5 pillars: operational excellence, cost optimization, reliability, performance efficiency, and security. Now, these 5 pillars are just an easy way to kind of understand the questions you're discussing amongst your team. But the important thing here is to understand they weave together. You can't just look at one. You need to look at all of them in context. Now, that may not line up with how your teams are set up today, especially, with the security side of things. But for me, I'm a firm believer that security is just one part of building well, and you need to integrate it tightly into everything that you're doing. More important than the 5 pillars. I know that's weird because that's how the framework is presented, but more important are the 6 core principles that are advocated by the framework. And the first is use on-demand resources wherever possible. Essentially, think of this one as idle resources are your enemy. You don't want to pay for them. You don't have to maintain them. They're just a waste of everything. So use on-demand wherever possible. You want to automate absolutely everything. If you're typing something into a command line, it better be to either A, test it out, and then to save it into a script that you can use for an automation, or just typing it directly into a script. You shouldn't be doing things by hand anymore. Long gone are those days. You also need to be testing regularly and at scale. We're going to dive into this principle with our first example in a couple minutes. And you need to be using fact-based feedback loops. If you've ever dealt directly or worked closely with the team at AWS, they have internalized this principle in an amazing way. And essentially what ends up happening is everything they do is based on a simple feedback loop of, if you have an idea, test it out with some metrics around it so that you can gauge how well it went, learn from that, iterate on the idea, and keep on going. A fact-based feedback loop, critical concept that helps you drive the evolution in your architecture. So even if you are comfortable sort of standing still, the AWS cloud is not. You are always getting new features, new functionality that can improve your builds. They can make things that used to take a whole chunk of code that you wrote by hand and turn it into a checkbox regularly. I guarantee there's at least one feature this during reInvent here over the 3 weeks that fits that bill for you. This is why you need to keep evolving your architecture. And my personal favorite, practice, practice, practice. You have to work through situations that if you have a failure or an outage or a bad code commit that gets deployed, how are you going to handle this? You want to practice that before you get in front of your customers or before it gets to production. So think of it this way. If you're a professional football team, there's no way that you're just going to go on the field to face your rival and hope that you win the match. That is not going to happen. You're going to run through practice. You're going to run through different scenarios so that when it comes to the game, you're prepared. We need to do the same thing in IT. Just it's, a lot less sweaty and much easier and a little more organized, but we still have the same principles. Practice, practice, practice. Now, before we go any further, let's just get this out of the way. No judgments. We're going to walk through a couple stories of teams that I've had discussions with that have shared their stories with me. I'm not going to give you specifics about who they are, but we are going to walk through these examples, and we need to practice that core engineering principle of, the blameless postmortem. Just remember, they made decisions that made sense at the time, given the constraints and knowledge they had. We're here to learn from it. They learned from it, and let's share that knowledge. So the first example we're going to use is a team that created a video streaming platform. So this was at the start of lockdowns around the world, and the available options commercially just didn't really fit the bill for them. They wanted something that was very niche. They could sell access to the streams to their targeted audience and then deliver customized content. Really straightforward, great business model. And they knew their niche was underserved, and they were a small team that wanted to deliver a quality solution. So the first thing they came up with, or what they're aiming for, I should say, as a goal, is this very standard thing. We've seen it a million times. You're probably looking at it right now. We have a live video window that is streaming this content that their customers have paid for. And then on the side, there's a live chat where you can connect with other people who are watching the stream at the same time, as well as the team delivering the content through the stream. Very simple, very straightforward. You can slap a number of different logos up on here. It's a very common interface example. And this is what they were shooting for. Great. This is awesome. This is going to meet the customer needs. It's going to be highly usable for their customers, given that familiarity. And this is the architecture that they started off with. Again, makes perfect sense, right? They've got an application load balancer out front. They've got a pool of EC2 instances running from one image that's in an auto-scaling group that runs their custom application. That custom application pulls data from Amazon S3 as well as Amazon Document DB instance. And behind the scenes, not pictured here, is the actual source of the streaming. It wasn't really relevant to our lesson, but just keep in mind there is a source streaming to an EC2 instance to spool that video out to the other instances in the scaling pool, in the scaling group. And of course, all of this is monitored by Amazon CloudWatch. Again, if you were setting this up with a small team, this makes sense. But you may have already spotted where there is one potential issue that may come back to bite the team. I say may, like it's not a foregone conclusion, but you know where we're going with this. The video and the chat functionality are running on the same set of instances, right? So they've tied those resources together. Again, that makes perfect sense. They started with a proof of concept, and as we all know, proof of concepts don't stay in the lab. It got rolled out to production with one easy to operate instance type. So what happened was in their testing, on the left, on the y-axis here, we have response time in seconds, so end-to-end what the user experience is. And on the x-axis, we've got the number of concurrent users. And the team ran some automated tests. And between 10 and 50 users, again, this data is normalized to make it easier to get the point across. Between 10 and 50 users, they saw a reasonable response time, 1 to 2.5 seconds, which was great. That was adequate for their needs. Customers were pretty happy. If you can get below 1 second, that's sort of ideal. The Nielsen Norman Group, who do a ton of UX research, have repeatedly generated the results that say under a second, and it just feels natural and fluid for customers. Over a second to, I think, 2 is basically it feels like the customer is interacting with something and it's responding in kind as opposed to a fluidity there. But anything over 2.5, you get to start to get worried. So as they creeped up to 100 users concurrently, they started to see these times increase. Now what you might be thinking is, well, wait a minute, aren't they selling tickets to this streaming platform? Yeah. And shouldn't they know how many people are coming to the stream? Yeah, they should. But what happened was the technical team had set everything up. They had run their tests. They were happy with its performance because they were testing with sub 50 users. And on the day of the stream, ticket sales spiked up very close to this chart. And they got more and more people coming onto the stream, which is, again, a great business success. The problem is the technical team wasn't aware of the spike in demand, so they weren't ready for what was coming, because as this increased to about 1,000 users, the response time was up to 10 seconds. Now, I don't know about you, but the last time I waited 10 seconds for anything on the web was probably about 1997, right? This is not acceptable from a user experience. So the users were very, very unhappy. They were leaving the stream. And in fact, as it crested closer to 10,000, which again is an amazing business success, they are delivering the streaming service into a very specific niche and seeing amazing response to their offer. The challenge is it got into this really weird scaling loop because people would request to access to the stream and the app, and that would scale out as appropriate. But by the time that scaling capacity was in place, those requests had been abandoned, and then more people would come in. And so auto-scaling was kind of trying to figure out, should I scale up? Should I scale down? And it just wasn't a good scene because they didn't test regularly at scale. They were testing at a very small amount, which they thought was adequate for their needs, but the capacity is there in the AWS cloud. It's going to cost you a few dollars to scale it out in your test, but wouldn't that be better than having egg on your face from crashing in front of customers? They also didn't practice. They didn't know what to do when things started to go wrong. And worse yet, because video and chat were tied together, they had no easy way to talk to their customers, and they had no backup plan. So they scrambled on social media, they scrambled through email, but it was not a good experience for either the team responding or the customers who had paid to this stream or the person that they were showcasing in the stream. All around, a lot of stuff could have been avoided by testing at scale and, more importantly, practicing to see, okay, if this crashes, what goes on? But let's take a look at this solution through the lens of the Well Architected framework. If we look at the pillars, operationally, it was okay. It wasn't that bad because they had that one image for EC2 instances that everything was spawned off of. So they kept the operations low. Everything was pretty much the same. Cost wasn't bad. They linked their scaling directly to paying customers. Of course, reliability and performance was not great. And the security was solid. They had to manage those instances, which is always going to bump up this pillar. But, not bad overall. This is pretty good for a first kick at the can, except for the fact that it failed utterly to meet their business requirements. Yikes. Very important to keep those in mind. So the team went back to the drawing board after that first disastrous day because they had other events lined up. And the first thing they did was they broke apart the application. They said, you know what? We can't have video and chat on the same thing. We need to separate them. We're going to put chat on its own pool of EC2 instances, and we're going to put video on its own separate pool as well. They didn't have to change the app to do this. They just rerouted things through the ALB. They routed chat to one pool, and they routed the video to the other. But this raised a couple questions as they were evolving the architecture. They said, this is a great evolution. We can do this really, really quickly, and we can test this out to see if it works. But are there other evolutions we can take to make our lives even easier? Well, it turned out they could. Since they had separated out the video, they started to ask the logical question, do we even need EC2 instances to serve out this video? That was a sort of a knee-jerk reaction. It made sense in a proof of concept. It made sense with a small team trying to get everything on one common instance type. But if we have to spin it out or split it out and have two different pools of resources, maybe there's a better resource. And it turns out there was. Amazon CloudFront distributions were a better fit for the team. There's a lot of great streaming functionality in CloudFront that will increase your performance because it gets geographically closer to the user. It's streamlined for delivering this type of content. So this was a strong evolution that made it a lot easier for the team to deliver a better quality product. It also, I would argue, follows the principle of using on-demand resources wherever possible. Now, I know what you're thinking, and wait a minute, aren't they using EC2 on-demand instances because they haven't figured out if they wanted to make a reservation yet? Oh yeah, they were, but that doesn't mean they were doing the best alignment of resources to cost that they could. And that's really what this principle is. I know that word on-demand kind of captures people because they think EC2 on-demand, but realistically what happens is with those EC2 instances, there was capacity that wasn't being used, whether that was CPU or network bandwidth. Moving to CloudFront, there's a direct relationship now between a customer accessing that stream and CloudFront serving it up, right? So there's every cost they have outbound for CloudFront is linked to income coming from that ticket. So it's a much closer alignment, and they don't have CloudFront sitting there idle that they're paying for it, right? CloudFront is only charging you for the bandwidth that you're consuming beyond the initial setup. So this is a much better alignment with this principle, which as a small team really helps. So operationally, they're still about the same because they still do have a pool of EC2 instances, but they've gotten better in the cost optimization. It's far more reliable, it's far more performant, and security is about the same because, again, they still have EC2 instances. So the team, having broken this apart, having shifted the video delivery through CloudFront, of course, is asking themselves, well, why is the chat app so big and so heavy? Well, it turns out again, doesn't need to be. There's in fact an example project on the AWS blog that shows the exact solution where the team started to lean towards, and that was a serverless-based solution with AWS Lambda, AWS AppSync, and then they switched to Amazon DynamoDB table in the backend because it was a much better fit for an online real-time chat. So moving this to an entire serverless design was a great evolution because, again, they're lowering their operations and they're aligning their on-demand uses of their resources, right? Great evolution. And then they're exploring yet another evolution here. They're actually looking at removing CloudFront because it's too much of a burden. They kind of got hooked on the whole serverless thing. They kind of got hooked on that, which is a great thing. They got hooked on the whole, like, what else can we move up the stack to a better, less touch service for us? And they're investigating Amazon Interactive Video Service, which is something that is a recently new service. And essentially it hides the CloudFront and S3 bucket usage in the background. And you have an endpoint you create in the service. You push your video to that endpoint, and then you use the services SDK to integrate it into your application, whether it's a web browser, mobile app, or what have you. So the team's in the phase just exploring this now to roll this out for their customers. And this goes to the core principle of automate all the things. If you've got things stable, if you're delivering a good value to your customer, is there something that you can do to make your life easier from an operational perspective? So customers won't see really a big difference with the Amazon Interactive Video Service, but the team will, because it's one less set of things they have to worry about, right? Now they'll have a highly managed service where they can just push video through and it scales out for them at a great rate and streamlines their back-end experience. So that ties in with automating it, because even setting up the distributions, worrying about the cache, worrying about the S3 bucket, that kind of stuff, if you don't have to do it, don't do it. And I mean, that was a much better solution than the instances, but this is an even better solution of going to a fully managed service fit for purpose. So if we look at overall where we are with the solution, operations is through the roof, cost optimization, everything we've done better. If we look at where we started, we've made significant increases. This is great work by the team. They've used multiple rounds based on facts they're seeing in each round. So they're using those feedback loops. They're evolving the architecture through lessons learned, right? Really great fit for them. And kudos to the team for making these improvements and moving forward. So let's use another example here. And this one was a team that I spoke to about their legacy system data storage. So they had taken an application that was designed for an on-premise environment. They were serving it out from their own data centers, and they're migrating it into the cloud. So they forklifted it into the AWS cloud, and then they're starting their experience from there. So again, we've removed some of the details just so that it's not obvious as to who we're talking about here, but there's some great lessons in this one. And we're going to look at this from a number of devices that are sitting out in labs around the world. And each of these are sending live data back. In this example, we're just showing weather data because it's something easy to relate. And there's a lot of different metrics coming in pretty much constantly. It's a real-time system that sends them to a central system in order to analyze the data and reference it. So there's a need to pull in real-time eventing, and then there's a secondary need for this analysis across all of these events. So this is a data-heavy application, and all of the good news is all of the processing is done centrally. So you may be screaming in your head, this is going to be an IoT solution, and it would be for part of it. We're going to focus on the data storage piece because I think this is where a lot of people are sitting, especially in large enterprise, where you have something that was built that is working, that is solving your business needs. In this particular case, was making a lot of money, but when they're moving into the AWS cloud, they're going along this journey that I think we've all been on, and so we want to highlight that. So if we look at the architecture, when they forklifted what they had into the AWS cloud, they moved the devices. We're talking to an Elastic Load Balancer, an ELB, that went to an Amazon EC2 instance pool in an auto-scaling group that was running their custom app. And in the back end, it was running an Amazon RDS Oracle instance or set of instances. And of course, they were monitoring it all with CloudWatch. This solution, now this is really, really important to call out. This solution is a forklift from what was on premises, and it worked great. It was highly reliable, it fit the purpose, and they had enough income to justify high licensing costs in Oracle. They were an Oracle shop already. So, as much, remember we said no judgments? No judgments. They were making a ton of bank off this. So you can probably figure out where we're going with this one as well, though. Some of the data and collection and analysis all being in an instance pool may cause some challenges here, right? But that's the important thing to think of. But it's that Amazon RDS Oracle instance where is going to pop up with our first example. So here we're looking at a chart again, normalized to make it easier for you. On the y-axis is the database size, right? So the amount of data that we're storing in the database in terabytes. And across the x-axis is our event volume in millions. So when we're looking at sort of 1 to 5 million, we don't have that much data being stored. When we hit 10, we're starting to creep into the, maybe 1 terabyte. When we get to 100 million events, we're at about 8 or 9 terabytes, and we quickly spike up north of 65, 70 terabytes when we're hitting 1,000 million events here. So, or groups of thousands of a million events. So the challenge is that, based on the facts that we're seeing, is that as these events spike up, our database costs are going to increase massively. They're going to follow this chart because storing data in a traditional RDBMS is going to be expensive. It just is. But again, this application was designed on premise and it was working fine. The challenge specifically is that per day, this team was seeing about 8 or 9 terabytes of data every day coming in. And that was only going up as they were being more successful. So why is that a problem? Well, because it's all being stored in the database, they were spending a lot of money. So if they're seeing about 8 terabytes a day, one of the maxed out 64 terabyte storage nodes, reasonably, savings on the 3-year reservation was costing them $15,500 a month after a $32,500 reservation over the 3 years. So remember again that they're filling one of these every 8 days. So every 8 days, they're spinning up another one of these nodes that's costing them $15,500. Again, they're making enough money that it's not huge, but it's an area of concern. So right now, if we look at the solution status across the pillars of the framework, operationally, it's fine. It's a little burdensome, but that's okay. It's not really optimized to cost, but it's not that bad because they're making money. Rock solid reliability, not great on performance because of those Oracle instances in the back end, and security is okay. But of course, the team's looking at that going, that's a big bill. So they start there. They switch that Oracle instance over to Amazon RDS Aurora. This requires a little bit of custom code change in their app, but not much. Doesn't fundamentally change how they're handling data. So when they switch this to an Amazon Aurora instance, for the similar performance and storage tier, that drops down to $8,000 a month and a $5,000 reservation. So they actually end up saving 49% through this code change, which is an absolutely massive win for the team. They were ecstatic about that because it was a minimal effort on their part and a huge savings on the back end. So this readjusts our pillars where cost optimization is now rising steadily because we've made one move to save 49% on our data storage costs. But of course, they're not stopping there. There's a lot more to do. They realize that, storing all the data in a relational database isn't really the way to go. Let's start taking advantage of Amazon S3. So instead of filling up a database every 8 days, now we can turn around and go, okay, we can keep some stuff live in the database, but we can start pushing more and more events out to S3, and that's going to cut our costs down significantly. Storing the similar amount in S3 was costing them around $1,000 a month. So significantly cheaper, way better for scalability. That was a great evolution in their architecture. They're taking advantage of the cloud. So this is a very common pattern we see. People forklift what they have because it was working, move it as is. Great step one. You should absolutely do that. But according to the well-architected framework, we should continue to evolve. And as we're evolving, we're taking advantage of other powers that are available in the cloud. So here we've cut down costs by switching to Aurora, and we're cutting down costs even more by moving some of that data that's not required to be available instantly through their custom code. And we can make it available in a different manner. In fact, they realized, wait a minute, we don't even really need the relational database in the way that it's existing. If we're willing to rewrite our data architecture and our code, we can start to leverage DynamoDB. Now, is that going to be cheaper than Aurora? Not necessarily. It ended up being less expensive for them, but it was more performant and they got a lot more flexibility. They were able to decrease the response time for requests in the backend, which was great. And this was all just changing their custom code. Again, evolving that architecture to see those results either back end for the team or front end for their customers. But they didn't stop there. They went even further because it's kind of addictive. They switched the ELB to an application load balancer, and they started using AWS Lambda functions for data ingest. And then they would decide if the data needed to go into Amazon DynamoDB table to update it. And they did some aggregate work in the Lambda functions right there and in Dynamo. And then they pushed a bunch of it into S3. And they moved a lot of their batch processing and their big analysis to Fargate. They took their custom code, they wrapped it up into a container, dropped it into Fargate in order to not only increase scalability, they decreased response time, which is great. And they also then made it less expensive and less operational burdensome on the backend team in order to make it easier to keep focusing on value as opposed to maintaining stuff. So they tested regularly at scale, and because of their tests, this is what they were finding. They said, hey, if we make these changes, we'll be able to scale better and continue to be successful, because they kind of hit this beautiful business snowball where labs started talking to each other and said, hey, haven't you seen this great service? And they started getting more and more customers, which was really critical for them to free up time to deliver more features because they had a broader customer base at that point. This also better aligns with using on-demand resources. They've eliminated those instances. They're spinning up those containers as required in order to do batch jobs, and they actually reduced the execution time of those batch jobs through this approach, which is great. And they automated everything, right? So everything is becoming highly automated, directly tied to customer demands. This is really just a really nice evolution of where they went. So if we look at the overall solution status, reliability stayed the same throughout, even though all the architecture has changed, which I think is a key call out. Performance is now through the roof. Security is easier because they've gotten rid of a lot of stuff. Cost is even more directly optimized to their revenue and their needs, and it's easier to operate. Overall, just a huge win by following the principles of the well-architected framework. So what do you need to take away here? What's the key? What do you need to understand? Well, the AWS Well Architected Framework is a freely available resource from AWS. You can get started with this right out of the gate right today. And it's all about finding the best solution at the time. That's key, at the time. There's no one best solution. You're never done. Either you're changing, the AWS cloud is changing, your customer demand is changing. The beautiful thing is you have the tools to meet that demand and to change with it, to innovate with it. You just need to be able to apply it in a logical manner, which is what the framework is all about. It does that through applying principles, the 6 core principles of the AWS Well Architected Framework. And they're really stuff that you were doing now, hopefully doing now, kind of felt instinctively was there. The framework codifies them, formalizes them a little bit better, removing those idle resources, automating everything, making sure you're testing at scale, changing and evolving your architecture based on data, and practicing for any possible scenario that could go wrong or even could go right, so that you're not stuck at a loss if something happens in production. The architected framework, for your ease of use, is divided across 5 main pillars. They do have individual deep dive white papers on them, as well as the AWS Well Architected tool is aligned to these pillars. But remember, the pillars are an easy way to look at it, but they connect. You can't have one without the others. You have to pay attention to all 5. Finally, the core idea of these feedback loops: have an idea, try it out, learn from it, iterate. Repeat that process. Just keep on going. That's how you're going to move forward. That's how you're going to build better. That's how you're going to build well in the AWS cloud. Thank you very much. My name is Mark Nunakoven. I'm an AWS community hero. I'm also the VP of Cloud Research at Trend Micro. You may have noticed from the -S on this session that it's actually a sponsored session, but you may have also noticed that we didn't talk about product. I think it's really important just to learn how to build better. Even though Trend Micro is a security company, we obviously sell security products, and you can learn more about those on our sponsored page or at trendmicro.com/cloud1. But we're firm believers that security is just part of building well, which is why I wanted to teach you today about the AWS Well Architected Framework. If you have any questions, you can always hit me up online at MarkNCA. Thanks a lot for attending. Enjoy the rest of AWS reInvent.